In this problem, we're just going to review a little bit more with areas of polars. So inside the limacon, 4 plus 2 cosine theta. Well, this is just a nice, beginning. We got 1/2 the integral of r squared. Remember that comes from a 1/2 base times height, where the base and height are approaching the same thing. So that's why it's r squared. The bounds on this, well, this one really is as easy as 0 to 2 pi. And how we would know that, if I plugged in 0, 4 plus, well, the cosine of 0 is 1, so 4 plus 2 is 6. And if you go around here, let's say you plugged in pi, cosine of pi is -1, so it's 4 minus 2. So this right here is theta equals pi. So 2 pi brings us back to where we started and encloses the whole area. Find the area inside of these two circles. So inside the red circle and outside r equals 1. So the area, and I'm going to lightly shade it here, the area we are talking about is here. Area inside the one circle and outside the other. What I always like to do with these is I like to draw a line from the origin to the spot where they intersect. It helps me to visualize exactly what we're talking about. Okay. And I might just kind of focus on half of it and go from there. Let's start by just figuring out an intersection. Let's start by setting these two equal to each other so we know where they meet. So we're looking for where cosine is 1/2. That is at pi over 3. So let me just start with that. Now, I like to think of this like a kind of a windshield wiper, like it's just sweeping through the area as we move. So, here's 0, and as we sweep through to pi over 3, what do we get? So I'm going to start with kind of that big outside function, and I'm going to say, all right, if I integrated that red circle, 1/2 r squared, let's just say from 0 to pi over 3, what would I get? Well, I'd start at 0, and would do this. So I get that whole thing. Well, I have to subtract out this other piece, this part of the circle, right? I have to subtract this out. So let me do this in blue. I'm going to subtract 1/2 integral from 0 to pi over 3 of r squared. And what that's going to do is subtract out this and give me what I want. Now, of course, it's actually going to give me half of what I want, so I would take this entire thing and double it, and that would give me the area. Now, you certainly could do this without the doubling. You could go from like negative pi over 3 to pi over 3, but I'd said earlier in another video that we should use the symmetry when we can. I think this is a good place to do that.